Hi guys, I hope you had a nice week off last week and enjoyed your Easter with your families. Today I'm going to be doing lesson 3-6, which is compound inequalities. You will need to turn to page 216 in your book. I am going to include the book pages in this video. So if you don't have your books, you can get those pages here. What I would like you to do first is go ahead and pause the video and do a heading for 3-6, compound inequalities. You can see the one vocab word is compound inequalities, of course. So go ahead, get that heading and vocab done, and then start your video again. So compound inequalities are inequalities that have two distinct inequalities, and they are going to be joined by either and or, one or the other. So it's either two inequalities joined by and, which means that they're both true, or, no pun intended there, or they're joined by the word or, meaning that they're essentially, when you graph them, they're going to go in different directions. So your book had a nice presentation on what those look like. You can see here we have the and side explained, and you can see we have two inequalities, so two distinct inequalities, and one of those inequalities here in red is x is greater than or equal to 3. The other inequality graphed in blue here is x is less than or equal to 7. When you put those inequalities together, you have an and situation. So we have x is greater than or equal to 3 and x is less than or equal to 7. Look what happens when you combine those graphs. So we're starting with the red graph and the blue graph. When we put those together, what we're saying is anywhere that this is true and this is true. So if you look here, you combine these two graphs, the area between and including, because they're both or equal to. So the area including 3 and including 7 and everything between 3 and 7 would be the solution here. So you're saying that it can be 3, it can be 7, or it could be anything in between 3 and 7 that is the solution. If you come over to the ors, these arrows you'll notice point in different directions and they don't meet up in the middle. So our first inequality graphed in red is x is less than -2. And then we have an inequality graphed in blue that is x is greater than or equal to 1. So notice this is an open circle because it's just less than. We don't have the or equal to. This is a closed circle because it does have the or equal to here. These two lines don't overlap at all, which is why we're going to have this or situation. We have x is less than -2 or x is greater than or equal to 1. If you combine the two graphs, we have our red graph just moves down to this line, and then our blue graph, also moves down to this line. There's no area of intersection for this to be an and. It just is an or in this case. It's either your answer, your solution is either going to be over here somewhere or it's going to be over here somewhere. And it can be either end and work. So we could plug 2 in, it would work. We could plug -3 in, it would work. If we plugged in 0, it would not work. It would not be a solution to this particular inequality. Notice down here it explains that when you have and connecting your two inequalities, there's two ways you can write it. You can keep it like they have up here and just say x is greater than or equal to 3 and x is less than or equal to 7. Or you can actually combine the two and make it nice and neat like this one. Remember, when you read left, you're going to start with your variable and say x is greater than or equal to, so you're reading that backwards. X is greater than or equal to 3, that's what we had up here. And then x is less than or equal to 7, that's what we have on our blue graph. You can combine those and say 3 is less than or equal to x is less than or equal to 7. So either way is fine. It's perfectly acceptable to leave it like this. It's just a little neater and tidier to combine them like this. Or does not have that option, or you have to just leave the two separate inequalities and put or between. All right, we are going to move on now to problem 1, which is just about writing compound inequalities. And our first example here says all real numbers that are greater than -2 and less than 6. So I hope you heard the and in there. So this is going to be an and situation, which means that we can simply write both inequalities like they have here. N is greater than -2 and n is less than 6. Or you can actually combine them and make it look like this. So when you're combining these, you are always going to have your smaller number on the left, bigger number on the right, and your inequalities are always going to be facing this way. So you'll notice a similarity amongst the ands. When you combine them, you're always going to have your smaller number on the left, your bigger number on the right, and you're always going to have both signs looking like less than. It might be less than or equal to, or just less than, but they're always going to be facing that way when you do these. So here we combine them and say -2 is less than n is less than 6. You would graph that as it is here. Both need to be open circles because we don't have the or equals, it's just less than. And you have one open circle here on -2, the other one on -6, and then the line in between. When we look down at B, it says all real numbers that are less than 0 or greater than or equal to 5. So an or situation means that your graph is not going to meet up in the middle. You're going to have two separate graphs pointing out. So when we do this, we just write it as it is. T is less than 0 or t is greater than or equal to 5. On the 0 side, you're going to have an open circle because you don't have the or equal to, and it's going to be pointing left. And then for the t is greater than or equal to 5, you're going to put a closed circle at 5 and be pointing to the right. What I would like you to do now is try Got It 1A and B. So pause your video, try Got It 1A and B, and then come back for the solutions. All right, so we have Got It 1A and B here. A said all real numbers greater than or equal to -4 and less than 6. So if you remember, we are going to always have our inequalities looking like this. Sometimes you're going to have the or equal to, sometimes you're not. You're going to put your smaller number over here, your larger number over here. So this one would look like this. -4 is less than or equal to x is less than 6. When you graph this, you're graphing your -4 and your 6. 6 is going to have an open circle because it's just the less than sign. 4, you're going to have a closed circle. And then because this is an and, you know that these are going to join in the middle. So I would draw it like that, showing that our solution set would include -4, would not include 6, but also includes everything between -4 and 6. Got It 1B says all real numbers less than or equal to 2.5 or greater than 6. So this one is an or, so we just need those two situations in our solution. So we're going to say x is less than or equal to 2.5 or x is greater than 6. Again, you're just leaving that or. We can't really combine this in any way. We just leave the or there. When you graph this, this means that these numbers are not going to connect. You're going to have a graph that goes out rather than in like the ands do. Here we had an or equals, so we're putting a closed circle. It's going that way. And here we have just greater than, so it goes this way. No, these do not meet in the middle. They do not overlap at all. When you're doing these crafts, please, please, please remember that your smaller numbers are always to your left. Your bigger numbers are always to your right. Remember that if you have less than or greater than, you're going to have an open circle. Less than or equal to, greater than or equal to, you're going to have that closed circle. So remember those. Let's move on to problem 2. Right, so problem 2, we are actually going to solve one of these compound inequalities. This compound inequality is joined by and. So what that means is both, sorry, my dog is crying. Both of the inequalities have to be met in order for this to be a solution to our inequality. So our inequality that they give us here is -3 is less than or equal to m minus 4 is less than -1. When they solve this, remember when you're solving any equation or inequality, your goal is to isolate that variable. So when we look at this compound inequality, we can see that m is less than 4 is in the middle here, and we want to get m by itself. So if we have m minus 4, then we are going to add 4. Now they are showing you that you can split these inequalities. So we can actually divide this into two separate. I don't recommend that necessarily. I'll show you how you can just keep it together and solve it. But in your book, it is showing you that you can split these inequalities and say -3 is less than or equal to m minus 4, and m minus 4 is less than -1. So they have split it into two inequalities. You're adding 4 everywhere, and you get your solution, and then they put it back together. Let me show you how to not split it and go ahead and solve it. So if we have -3 is less than or equal to m minus 4 is less than -1. We can actually just keep this compound inequality together and go ahead and add 4. Just remember that when you add 4, you need to add it to all of your sections. So we're going to add 4 here, we add 4 in the middle, and we add 4 here. When you do that, over here we get 1 is less than or equal to m is less than 3. So notice that's the same exact inequality that they got in your book when they combine them. I find this to be easier when you keep them together. You just have to remember, if you do something, do it to all of the sections of your inequality. Also, remember back to when we saw these, pretty much everything is the same as if there was an equal sign in there. The difference would be if you multiply or divide by a negative number, you're going to have to flip all of your inequalities around. So here we have our solution, and we can go ahead and graph it and say we have a closed circle here, an open circle here, and it's an and, which means they're going to come together in the middle. Go ahead and try got it 2. Pause your video, try got it 2, and then come back for that solution. Alrighty, so got it 2 was -2 is less than 3, y minus 4 is less than 14. So you can see we have a compound inequality. We also have a two-step equation happening. So, two-step inequality, I should say. So the first thing we need to do when we're trying to isolate our variable is get rid of the -4. So again, just like the last one, we're going to add 4 to all of our sections. -2 plus 4 would be 2. This would be 18. So next thing we would do is get rid of that 3. It's 3 times y, so we're going to divide all of our sections by 3. We then can say those cancel out, so we just have y in the middle. Over here, I'm just going to leave this 2/3 because algebra does in fact love fractions. 18 divided by 3 would be 6. So here's our solution. When we graph that, we're going to just put our 2/3 are 6. They're both open circles because we had no or equal to. This is an and, so they're meeting in the middle. And we are saying by this graph that anything between 2/3 and 6 would be a solution for that inequality. To check this, we could pick something in here. So I'm going to pick 0 because why not? When you can pick 0, pick it. So we would rewrite our original. Plug in 0 everywhere there's a y. And check to see that this is true. So -2 -2, something happened. Oh dear, I was thinking this was a -2/3. It is not, it is +2/3, which means that 0 is actually way over here, so we can't use 0. It would not work, as it didn't. This is not true. So I'm going to change this to something that's actually between 2/3 and 6, and I'll say 1. So 1 minus 4 would be -3. -2 is in fact less than -3. -3 is less than 14, so we know that we're good now. And that was a perfect example why we might want to do a check to make sure we are good there. And we weren't the first time, but that's because we were using something over here, which should not have worked, and it didn't. So moving on to problem 3, we have our token word problem here. And it's talking about averages, test averages. And it says you want to earn a B in your algebra course. I hope you all want to earn A's, not B's. And to do that, you must achieve an unrounded test average between 84 and 86 inclusive. That means that you can have an 84 and an 86 or anything in between. You scored 88, 85, and 90 on the first 3 tests of the grading period. What possible scores can you earn on the 4th and final test to earn a B in the course? So what they're showing us here is the compound inequality that you could use to solve this. Notice it has to be 84 or larger, and then it has to be 86 or smaller. So somewhere between 84 and 86 will get you a B. They have the first 3 tests here, and your variable comes in for the 4th test, because we don't know that. To figure out an average, you of course add your numbers and then divide by how many there are. So they've added the first 3 that they know, simplified that a bit. And then to get rid of the 4, you multiply all of your sections by 4. So they've done that, and then you simply subtract this from everywhere and you end up with X. So you can get an 85 to a 93. So again, we're including 85 and 93, and anything in the middle would be fine. So if you got 85, 86, 87, 88, 89, 90, 91, 92, or 93, you would have your B for the term. Go ahead, try got it 3, which you could see is set up be a very similar problem here. It says your first 3 tests were 78, 78, and 79, and you want to know, is it possible to get a B for the course? Assume that 100 is the maximum grade that you can get, but you're supposed to figure that out and decide why. So we actually can set this up very similar to our first example there, and we are going to use the same outline numbers of 84 and 86. This seems like a really small range for a B, 84 to 86, but apparently at this fictitious school, that's the B range. So when we do this, we this time have 78, 78, and 79, and we're going to add our 4th test and divide by 4 because there are 4 test scores. So the next thing that we would need to do is add up 78 plus 78 plus 79. And then we know that we are going to have to multiply by 4 everywhere. So we can go ahead and multiply by 4. We have to do that everywhere. Oops. So and they had already done that multiplication for us. So when, oops, I forgot my plus x. When, oh, I'm sorry. These 4's canceled out. I didn't need to multiply that. I did some extra math there, that's okay. So now we would subtract 235. Here we get 101. looking good for a B here. When we subtract over here, so unfortunately, we would have to get somewhere between a 101 and a 109. And in the problem, it said that we were to assume that 100 is the maximum, which means, unfortunately, for the student, there is no possible way for them to get a B for the quarter. They would have to get a very high mark on this test to earn a C for the quarter. So that would be got it 3. And we can now move on to problem 4. Problems 1, 2, and 3 all were regarding our AND situations. Problem 4 brings in the OR. So in this case, we have 2 separate inequalities, and they will just stay separate. We have 3t plus 2 is less than -7, or -4t plus 5 is less than 1. So in this case, you essentially have 2 separate inequalities that you're going to graph, and then you're going to take your answers for those 2 inequalities and just put them together with OR in between. When you graph them, remember that these should not overlap. So be careful with your signs here. If you have an OR, your arrows should definitely be pointing out. They should not be pointing in. Sometimes people will forget to flip their inequality when they multiply or divide by a negative number, and they end up, when they graph, they notice that they have one arrow that, say it's going to the right, and they go to graph their other arrow, and they know it should be going left because of the OR, but really what they got is another arrow pointing this way. If that happens, you made a mistake somewhere. You made a math mistake. Chances are very, very likely that you forgot to flip an inequality. So in this example here, they have solved these out for us. You look for your variable, you try to isolate it. You have to get rid of terms that don't have your variable first. So they subtracted 2 from both sides, then divided by 3. Got t is less than -3. The next inequality, again, you look at the side with your variable, get rid of the term without the variable first, and subtract 5 from both sides. Then we divide by a -4, and t is greater than 1. Watch your open and close circles. So in both of these cases, we just have a less than, greater than. We don't have any or equal to's. So we're going to use open circles for both. And over here, we say that t is less than -3. Here, t is greater than 1. Go ahead, pause the video, try got it 4, and come back for that solution. All right, so we are on got it 4 here. You can see I have my inequalities up on the board, and this is an OR situation. I recommend when you have an OR that you write your first inequality and then write OR between, and then your second inequality. You are then going to solve your inequalities. Notice here I'm going to divide by a negative, which means that inequality has to flip. So I'm saying y is greater than 3. And then over here, I'm going to solve this one out. Here I'm dividing by a positive, so my inequality is not flipping. And I come up with my 2 inequalities in my solution. So when I go to graph this, remember your smaller number always has to be further to the left, your bigger number further to the right. With my 3, I have an open circle, -2, I have a closed circle. And my hope here, because we have the OR, is that my solution should be outward arrows. So let's check that out. Y is less than or equal to -2. So that in fact does go that way, and y is greater than 3 is going to go this way. But I do have those outward facing arrows, which I should look for with my over. If I checked a number in between here, so say 0, I would check it in both of my inequalities and it should not work for either one. So over here I do -2 times 0 is 0, plus 7 is 7. 7 is not less than 1. Over here I would say 4 times 0 is 0, plus 3. So 3 is less than or equal to 3 is less than or equal to -5. That does not work. Oh, this one did not work either. We're good. That should not have worked in either. So on this side we get 7 is less than 1. It's not, it's greater than. And over here we got 3 is less than or equal to -5, which it's not. 3 would be greater than -5. If we try something over here, it should work, and if we try something over here, it should work. So we could try -3, we could try 4, and those should work in our inequalities. When you finish this up, I want you to flip to page 220 in your book, and I will include this in the assignment. So if you don't have your book, look for the attachment of this page in the assignment on Rediker. And what I would like you to do is page 220, and I want you to try 8 to 22 even. And when we meet this afternoon, I would love to have you ask any questions that you have on these problems. So hopefully you'll have time to watch this and do the assignment. If not, that's perfectly fine. I will post answers to it then later. But if you can, get this done before our Zoom, which is at 1:30. I sent your parents an email with that Zoom information. I will also put a link on Rediker with it as well. See you all later today.